Hello students, welcome back to chemistry class. So in the last class we have studied about the what is meant by chemical bond and the contribution of the Cosell and Lewis in order to explain the formation of chemical bonds, and also we have studied about the octet rule, right? So according to Cosell and Lewis theory, those atoms having the 8 electrons in the outermost orbital, that atoms are more stable. So only noble gases have 8 electrons in the outermost orbital. So that is to be called as noble gases only has octet structure. So the rest of the elements does not have the octet configuration. So in order to get the octet configuration, either these atoms loses electrons or gains electrons, or on mutual sharing it gets the octet configuration. So that was explained by Cosell and Lewis. So in this class we are going to study about the what are the different types of bonds, right? So already we have studied about what is a chemical bond. So chemical bond is nothing but it is a force of attraction that holds the constituent particles together in a chemical species. So that force of attraction is generally to be called as chemical bond. So there are different types of force of attractions that holds the constituent particles together in a chemical species, and that force of attractions are to be listed here. So first one, that is ionic or electrovalent bond, and second one covalent bond, and third one coordinate covalent bond, and fourth one metallic bond, and fifth one hydrogen bond, and the last one, that is van der Waals force of attractions. These are the different types of force of attraction. So that different types of force of attractions are generally to be called as chemical bonds, right? So these are the different types of chemical bonds that holds the constituent particles together in a chemical species. Let us see one by one. That is first one, ionic or electrovalent bond. So we all well know that. So the name itself indicates that ionic bond. That means this bond is to be formed between the ions. So ions is nothing but cations and anions. That is, the ionic bond is formed by the transfer of one or more valence electrons from a metal atom to the valence shell of a non-metal. For example, let us take a metal atom. So generally first group elements and second group elements are metals, right? All the first group and second group elements are generally metallic in nature, and p block elements, that is most of the p block elements are generally non-metals. So I am taking only the halogen family, that is group 17th elements. So 17th group elements are generally non-metals. So this ionic bond is formed between the metals and non-metals. That is, ionic bond is formed by the transfer of one or more valence shell electrons from a metal atom to the valence shell of a non-metal atom. Why metals transfers electrons to the non-metals? Because in order to attain the noble gas configuration. For example, let us take sodium. So sodium electronic configuration is, that is neon, and it is 3s1. So it has 11 electrons. So in that 11 electrons there is an 1 electron in the outermost orbital. So to attain the noble gas configuration, so the loss of 1 electron is easier as compared to the gain of 7 electrons. So the metals readily loses electrons. So it gives Na plus configuration. So Na plus means it loses 1 electron. That is, 1 electron is to be represented in the product side. So the configuration of the sodium is neon. That is, Na plus electronic configuration is similar to the electronic configuration of neon. So the one electron present in the 3s1 orbital comes out from the sodium atom. And let us take a non-metal atom, that is generally Cl. So Cl has configuration that is neon, nearest to noble gas configuration, and the outermost orbital is 3s2 and it is 3p5. So there are 7 electrons in the outermost orbital of chlorine. So this chlorine gains 1 electron. So that electron generally released from the sodium atom. So that electron is to be gained by the Cl and it gets the Cl minus. So that minus indicates the presence of 1 extra electron. So the configuration of the Cl minus is neon and it is 3s2, so it is 3p6. So 1 electron is increased in the chlorine, right? So the outermost orbital gets 8 electrons. That is, Cl gains 1 electron from the sodium and it is to be converted into Cl minus. And this neutral sodium atom loses 1 electron and it is to be converted into Na plus. That is, the metal atom which has lost electron is converted into positive ion. So this positive ion is to be called as cation. Cation. So cation is nothing but the positively charged particles. So positively charged particles are generally to be called as cations. And the non-metal atom which gains electron and is converted into negative ion. So the non-metal atom gains electron and it is to be converted into negative ion. So this negative ion is to be called as anion. So negatively charged particles are generally to be called as anions. So very important, when metal atom loses electrons and it is to be converted into positively charged ions. So these positively charged ions are to be called as cations. And the non-metal atoms gains 1 electron and it is to be converted into negatively charged ions. So these negatively charged ions are to be called as anions. So the cations and anions thus attain the noble gas electronic configuration, right? So both the sodium as well as, that is Na plus as well as Cl minus attains the nearest noble gas configuration. So ionic bond is defined as it is an electrostatic force of attraction between the cations. So in this example, cation is Na plus and anion is Cl minus. So there is a certain electrostatic force of attraction between the cations and anions. So that electrostatic force of attraction is to be called as electrovalent bond, or it is also called as ionic bond. That is, ionic bond is defined as the electrostatic force of attraction between the cations and anions, resulting in the formation of ionic crystal. So that leads to the formation of an ionic crystal. So the force of attraction is generally to be called as ionic bond. Ionic bond. So very simple concept. So ionic bonds are formed by the transfer of electrons from valence shell of one atom to the valence shell of another atom. That is, generally transfer of valence electrons from metal atom to the valence shell of the non-metal atom. So ionic bonds are generally to be defined as it is a force of attraction. Generally it is an electrostatic force of attraction. Why it is to be called as electrostatic? Because there is an force of attraction between the oppositely charged ions. So that force is to be called as electrostatic force. So electrostatic force of attraction between the cations and anions are generally to be called as ionic bonds. Similarly, let us take one more example, that is the formation of calcium fluoride. So calcium has configuration, that is argon, and it is 4s2. So there are 2 electrons in the outermost orbital of calcium. So this calcium loses 2 electrons and it is to be converted into Ca2 plus and 2 electrons. So it gets the configuration of noble gas, that is argon. And this fluorine has configuration, that is helium and 2s2, so it is 2p5. So it requires one more electron to get the octet configuration. So it gets one electron and it forms F minus. So this F minus has configuration, that is helium 2s2 and it is 2p5 plus 1 electron, that is 2p6, right? So this configuration is similar to the configuration of neon. It is similar to the configuration of neon, that is calcium 2 plus and 2 F minus ions has certain force of attraction and it forms a molecule that is to be called as CaF2. That is 1F gains 1 electron. So 2F gains 2 electrons, that is to be released from the calcium. So it forms a molecule that is to be called as calcium fluoride, CaF2, or it is also to be represented as Ca2 plus and F minus, and it is twice because it contains 2 fluoride ions. So this is the formation of ionic bond. So the ionic bond is just electrostatic force of attraction between the cations, electrostatic force of attraction between the cations and anions. So that force of attraction is to be called as ionic bond. Ionic bond. And next let us see the factors which are favorable for the formation of ionic bond. So mainly 3 factors which are favorable for the formation of ionic bond. So in that first one, that is low ionization enthalpy. So what is this low ionization enthalpy? So ionization enthalpy is nothing but, that is ionization enthalpy is nothing but energy required to remove valence electron from neutral atom. So the amount of energy required to remove a valence electron from a neutral atom is generally to be called as ionization energy. So this ionization energy for the metals always low. So the low ionization energy of the metals favorable for the formation of ionic bond. So if the ionization enthalpy is very low, then the metal easily loses electrons and it is to be converted into cations. That is, if lower the ionization energy, so metals are easily to be converted into cations. And the next point, that is high electron affinity. So electron affinity is nothing but the amount of energy released when an electron is added to the atom. So the amount of energy released when an electron is added to the non-metal, that energy must be high. So greater the electron affinity, greater will be the formation of ionic bond. So for example, let us take a non-metal atom. That is, the non-metal atom is chlorine. That is Cl. So this sodium contains 7 electrons in the outermost orbital, right? There are 7 electrons in the outermost orbital. 3, 4, 5, 6 and 7. So in order to add one more electron to the chlorine, in that case, when electron is added to the outermost orbital of the gaseous atom of an element, certain amount of energy is to be released. So that is to be called as electron affinity. So that is to be called as electron affinity. So electron affinity is to be defined as the amount of energy released when an electron is added to an isolated gaseous atom of an element. So the higher the energy released during the process, easier will be the formation of the anion. That is, higher will be the energy released during this process. In that case, easier will be the formation of an anion. So for the non-metals, the electron affinity must be high, and for the metals, ionization energy should be low. And then last point, that is high lattice energy. So lattice energy is defined as the amount of energy required to remove 1 mole of a compound into its gaseous anions. For example, let us take sodium chloride. So the ionic compound, that is sodium chloride. So the amount of energy required to separate this sodium and Cl into, that is Na plus gas and Cl minus gas. So the amount of energy required to separate 1 mole of an ionic compound into its gaseous ions, that energy is to be called as lattice energy. That is, there are 3 factors are favorable for the formation of an ionic bond. One is, for the metal atoms, it should be low ionization enthalpy, and for the non-metal atoms, it should be high electron affinity. So greater the electron affinity, easier will be the formation of an anion. So lower the ionization enthalpy for the metals, easier will be the formation of the cations. And for the compounds, if it has very high lattice energy, that compounds are generally stable. So higher the lattice energy for a compound is favored for the formation of ionic bond. So these are the 3 factors which are favored for the formation of ionic bond. So ionic bond is nothing but the electrostatic force of attraction between the cations. Cations are nothing but positively charged ions, and anions. So anions are nothing but negatively charged ions. So the force of, that is the electrostatic force of attraction between the cations and anions, are to be called as ionic bond. And next, let's see second type of chemical bond, that is covalent bond. So during the formation of an ionic bond, there is a transfer of electrons from one atom to the another atom. In the formation of covalent bond, there is no transfer of electrons, just there is an mutual sharing of electrons from one atom to the another atom. So what is this mutual sharing of electrons? That is, during the mutual sharing of an electron, that is generally the formation of a covalent bond, the two combining atoms contribute equal number of electrons for sharing. That is, for the formation of covalent bond, the two contributing atoms contribute equal number of electrons for sharing. For example, let us take formation of hydrogen molecule, that is H2 molecule. So between the two hydrogen atoms there is a certain force of attraction. So that force of attraction generally a covalent bond. So let us take an atom of hydrogen. So that is one hydrogen atom and one more hydrogen atom. So in each hydrogen atom contains one valence electron. That is, both the hydrogen atom contains one electron. So the electronic configuration for the hydrogen atoms is 1s1. So it contains one electron. So during the formation of a covalent bond, the two contributing atoms contribute equal number of electrons for sharing. So the shared electrons contribute equally to both atoms, and both the atoms attains octet number of electrons. Let us see how these two electrons are gets mutual sharing. That is, the electron present in the hydrogen atom from one atom to another atom on sharing, and this electron is to be mutually shared with the another hydrogen atom. So it is to be represented as into mark. So that into mark is an electron on mutual sharing. So this hydrogen atoms contains one pair of electrons between the atoms. That is, both the hydrogen atoms contains the nearest noble gas configuration. Let us see how it contains the nearest noble gas configuration. So between the hydrogen atoms it contains one pair of electrons. So one electron from one hydrogen atom and another electron from the another hydrogen atom on mutual sharing. There is one pair of electrons between the two atoms. So these two electrons are responsible for both the hydrogen atoms. That is, the shared electrons contribute equally to both the atoms, and both the atoms attain octet number of electrons in the valence shell. So in the case of hydrogen there is a doublet configuration, because the nearest noble gas for the hydrogen is helium. So it gets the doublet configuration. That is, this hydrogen also contains two electrons and this hydrogen also contains two electrons, right? So the bond is to be formed by the mutual sharing of electrons. Mutual sharing of electrons. So by the mutual sharing of electrons, certain force of attraction is to be formed between the atoms. So that force of attraction is generally to be called as chemical bond. So ionic bond is formed by the complete transfer of electrons from one atom to the another atom. That is especially from the metals to the non-metals. But here there is no transfer of electrons, just on mutual sharing of electrons between the two atoms. So certain force of attraction is to be formed. So that force of attraction is to be called as chemical bond. And let us see a few more examples of the formation of a covalent bond. That is the formation of covalent bonds in chlorine molecule. Formation of covalent bond in Cl2 molecule, that is chlorine molecule. So let us take chlorine molecule. That is, atomic number for chlorine is 17. So its electronic configuration 1s2, 2s2, 2p6, and it is 3s2 3p5. That is 1s2 2s2 2p6 is simply represented as neon, and the outermost configuration is 3s2 and it is 3p5, right? So the chlorine atom contains 7 valence electrons. So 1 2 3 4 5 6 and 1 7. Let us take one more chlorine atom, and this chlorine also contains 7 valence electrons. So, and mutual sharing of these electrons and mutual sharing of this single electron present in the chlorine atom, it gets a covalent bond between the atoms Cl, Cl and Cl. So one electron from one chlorine and one electron from the another chlorine. So finally this chlorine atom also contains 8 electrons, and this chlorine also contains 8 electrons, right? So, and mutual sharing of electrons, that is, and mutual sharing of valence electrons, that is, the mutual shared electrons are equal number of electrons, right? So that electrons leads to the formation of a covalent bond. That is, on mutual sharing of electrons, each atom gets 8 electrons in the outermost orbital. So the electrons are responsible for the formation of a force of attraction between the two atoms, are generally to be called as bonds. So that bond is a covalent bond, right? And let us take one more example, that is the formation of water molecule. Formation of water molecule. So this oxygen atom contains 2 lone pair of electrons, and totally there are 2 plus 2 4 and 2 6 electrons. So atomic number for oxygen is 8. So its electronic configuration 1s2 2s2 and it is 2p4. So the outermost orbital contains 6 electrons. So this is to be called as 6 valence electrons, right? So these 6 valence electrons, that is, out of 6 valence electrons, 2 valence electrons are mutual sharing with the valence electrons of the 2 hydrogen atoms. That is, hydrogen contains 1 electron, right? So the molecule of water is to be represented as like this. That is, the hydrogen contains 2 electrons, and this hydrogen gets 2 electrons, and this oxygen gets 8 electrons. That is, in outermost orbital it gets the 8 electrons. So there is a certain force of attraction between the oxygen and with the hydrogen atoms. That force of attraction is to be formed by the mutual sharing of electrons. That mutual sharing of electrons force is generally to be called as covalent bond. That is, covalent bond is to be formed by the mutual sharing of electrons. And let us take one more example, that is carbon tetrachloride, CCl4. So carbon contains 4 valence electrons, and the Cl atom contains 7 valence electrons. So 1 electron from the Cl, and here 1 electron, 1 2 3 4 5 6, and the Cl. So 1 2 3 4 5 6 7, and the Cl. So 1 2 3 4 5 6 7. So all the atoms gets 8 electrons on the outermost orbital. So it is 8, and it is also 8, and it is also 8. and the central atom also gets 8 electrons. Central atom also gets 8 electrons. That is, on mutual sharing of electrons, all the atoms gets 8 electrons in the outermost orbital. So that force of attraction is generally to be called as covalent bond. So covalent bonds are to be formed by the mutual sharing of electrons.